Hey everyone, Ariel Adams at SIHH 2017 with Ulysse Nardin. aBlogtoWatch is going to explain the new InnoVision 2. This is a concept watch. A few will be built. They will not be sold officially. I wish I could get one, not that I could afford one. This is a fantastic watch, and we're going to learn about the 10 innovations that go into the InnoVision 2.
You had direct impulse from the oscillating wheel directly to the wheels.
Now tell people that may not understand why you would want to do that.
That you don't lose any, or that you don't create more friction than you would already have. That was the idea behind this.
Increases efficiency is what you're saying.
Exactly. Now what we did 2 years ago with the flying anchor, we call it the Ulysse anchor escapement, we made it constant. So now for this concept watch, we combined and evoluted what we did. So we took the dual direct,
because each of these ticks is the exact amount of power.
Exactly, because those blades create always the same amount of power.
Right.
But what we did now, we took that Ulysse anchor, combined it with the dual direct, and made it constant. Because this is the way it works in the fleet. This is important. Today we see everywhere that constant escapement or constant power is becoming more and more efficient.
Yeah, constant force escapement.
Exactly. So now that was the first thing which we did. You know, we are the leader in silicium technology.
You sure are.
So now what we did, we came with another patent which we put in here. It was the first time that the company bonded silicium. Why did we have to do this? Because we had different heights in material. So
let's just explain again. I just want to make sure everyone gets this, because you and I understand this, but I think that when someone sees a picture like this, they're like, "This is really cool. I don't know what I'm seeing." So when you cut a piece of silicon, it's just one piece.
It's one piece.
Until now, it wasn't able to bond pieces to make more complicated parts.
Exactly. So now we have more opportunities. And what we did here, there's a part here which is dark, which we bonded. Why did we do that? Because if you have a waver, the silicium part is always of the same height.
Exactly.
But in the creation here, we needed to have a pin within here. So the pin, of course, is higher than the normal piece, than the regular piece. So what we did, instead of wasting an entire waver, we wave out one part, and from a different, thicker waver, we wave out the pin.
And how did you bond them?
Then we bond it.
How?
That's our patent.
Oh, that's the secret.
That's the secret.
Is it a very stable bond?
Yes, absolutely.
Okay, because people, of course, that's the worry, because I think it's a glue.
No, it's not a glue. It's
Clearly
a bonding. It's a bonding. Yeah,
Yeah.
it's a bonding, which is a similar situation which we have with Liga technology, which we do, dry technology. It goes in that technology.
Did you develop this, or is this taken from some other industry? And you're like,
we developed it.
Fascinating.
We developed it. Yeah, together, of course, with Mimotech and with SIHH.
That could be a valuable patent.
Very valuable.
Awesome.
And we will see this being used for more complicated timepieces in the future.
I mean, that's a game changer.
Absolutely.
Total game changer.
Plus, this whole escapement, if I show now the entire part, we have a total of 4 patents in here, including the bonding part which is in here.
I mean, just that looks awesome.
Very complicated.
So you have, this is more than 10 years ago, over 15 years old now, this concept, added to the constant force escapement.
Yes, which we came out 2 years ago with the flying anchor, or the Ulysse anchor. And this concept was a new escapement which was developed by Ludwig Oechslin about 20 years ago and launched in the Freak 15 years ago.
And it could never be done in metal, it had to be done in silicon?
In this case it had to be, because of the high friction we would have and the high speed, because it is a direct impulse which comes from the oscillating wheel directly into the escapement wheels.
I can't wait to see a video of this thing working. It's a little, it's abstract, right? You have to see a little bit.
You will see that in a minute, hopefully, if you can tape it.
So dual escape wheels plus constant force escapement.
Exactly, and we call it the dual constant.
Dual constant.
Exactly. Now the next one, which I would like to show you, and I don't have really a better drawing than this. This is the oscillating wheel, which looks very complicated, very complex. It's made out of silicium, one part with 4 parts in gold, where we can do the inertia correction. You see those paddles, those are all paddles. The paddles are here because in a timepiece, in a mechanical timepiece with an oscillation of 28,800, you have wind.
Right.
You have a wind flow and you have a certain whirl which is going on. which has an influence on the timepiece's accuracy if you lie it down flat or if you have it straight up.
Sure.
With those paddles, you can control the flow of the air to a certain extent.
And you just turn them a little bit?
No. They are calculated
fixed.
the way they're fixed. But through those paddles, the wind flow is controlled.
Interesting.
And it adds, of course, to the accuracy.
Because that's always the biggest problem, is air resistance.
It's exactly, it's part of the problem. There's
Well, yeah.
of course more, there's
Friction,
friction,
all but
there's
some
air.
type of resistance.
It's part of the resistance, and
Yeah.
it helps with the accuracy, particularly with the tolerance between flat position or
That's got to be one of the
vertical
most
position.
complicated, like, single pieces of silicon I've seen. And of
It
course,
look-
that's gold on there.
It
but-
looks like it, but because we master the technology and it's etched out of one piece, it is a technology which
I mean,
we
no
know,
one's
which
ever
we know.
seen it, like a
No.
balance wheel that looks like
Not
that.
that complicated.
Fantastic.
No.
Now, grinder. The word grinder's interesting.
Yes.
And it's your version of an automatic.
Yes.
When I read this, I read it like several times to try to
Yes,
understand
yes.
it. But I'm really happy you're going to explain it to me now.
I have a model to show it to you. I have to grab this model here from the back.
We're going to see a model of grinder.
I have to explain it in a way. This is the final piece, the way it looks on a timepiece. You will see here 4 levers. 1, 2, 3, 4, right?
Mm-hmm.
You will see that in the model afterwards. So I need to talk quickly about those 4 levers. In a regular winding system, like any automatic rotor has, like this, you have always 2 levers.
Right.
Here we have 4. The advantage here is when you take a bicycle as an example, you have 2 pedals. You always have an idle part, and you always have the part where you have torque. You
Yeah.
have torque, you're idle. You have torque, you have idle. Now you imagine you would have 4 legs and you would have 4 pedals. You're going to gain on torque. And that's the idea. That's the basic idea of efficiency of this winding
So
system.
this would be underneath the weight?
No, there's no weight.
There's no weight?
There's no weight. That is it. I'll show
Okay.
you here in this
Oh, wow.
in this example what that means. So,
You came very well prepared.
well, I have to because this is fun, you know.
This is awesome.
This is the fun. Now, I move this disc very slowly. You see, this is the winding system. If I would hand wind it, you know, in a freak you wind from the back. So you wind here the mainspring. Normally, with a rotor you have again this idle part until the rotor starts. When it swings from left to right, you have an idle part. Here, the smallest move, the big move, any move, wherever direction I go, it always winds.
Oh my God, that's brilliant.
You can do it yourself.
No,
Whatever you do, whatever direction you go, it's always winding. The slightest move will wind it.
I mean, I completely understand. So this is essentially the weight, and it's the vibration of the watch.
It's the vibration of the watch, but now what we did a semi rotor which goes around here. It's hard to see here, but there's a rotor going around inside, a semi rotor going around this system,
So it further
and
increases
gives an
the
impulse and
efficiency.
further increases it. So it's not only the move, it's even the rotor which goes aside, which keeps this moving in all directions at all times.
Can this be industrialized in any mass way?
Well, we have it here, and it's for sure, I can tell you, my goal that we will industrialize it, and that at some stage we will see it, because it's obvious you don't have a rotor on top of it, which means we are saving space.
Yeah, and it looks a lot more efficient.
It looks very efficient because the slightest move will always make it
So
wind.
here's what I'm thinking when I see this, right? One of the biggest problems in technology where we wear something that has battery life is power generation.
Yes,
I see something like this maybe in the future being used to generate electricity.
yes.
Especially something like this
Yes.
is new because, like you said, the rotors now that exist, you need a lot of force.
Mm-hmm.
It's not super efficient, especially when it comes to generating something else. But something like this, imagine having a bunch of these.
Yes.
You could be generating electricity. And so that's what's exciting about this. I see patent. Yes, it's amazing for mechanical watches, but here is at least the idea.
It
It's
could
something
lead,
for
it
watches.
could lead to something else.
Yes.
Sure.
And that's
absolutely,
awesome. Wow, this
absolutely.
is
So this is of course very well illustrated here, and I think it's very obvious that the efficiency is there.
that's brilliant. Again, seeing the pictures of it, I couldn't have understood it.
Yes.
Now that makes
You
sense.
see
It almost
what's
looks
happening.
magic. It almost doesn't look like it should be doing this.
Yeah.
Because you think any direction you move it, and this wheel is moving the same way. That is
It's awesome, huh?
really cool.
So this is, of course, again covered with 2 patents here, you know. So you see that InnoVision
Wow.
timepiece number 2 is fully loaded with all kind of patents. Then the next one, which I would like to show you, is a bridge which we produced. You know, we started with silicium in the year 2001. We then did some parts out of diamonds, pure diamonds. What we did later on then was diamond coated silicium.
Diamond sill.
Diamond seal. Now what we are doing for a while already, and we have the patent already issued for that, this patent is already granted, we take silicium and we coat it with sapphire.
So here's a question. What does this improve on that the diamond sill didn't give you?
Of course there's a cost factor.
Okay.
Sapphire and diamonds.
You mean diamonds are expensive? Weird.
Well, makes sense, right? But then again, you're testing. Don't forget, it's a concept watch, and now you're testing this,
To see how it
and we
works.
will see how it really gonna react. But of course, the hardness of sapphire is the same or almost the same as diamonds. Not quite, but almost, and it has a lot to do with hardness.
So this could be the solution to the brittle nature of silicon that sometimes watchmakers worry about?
Yes, I think it's only the watchmakers that worry about it, that have to put it together.
Right.
Because we don't get any parts coming back broken.
Interesting.
And I would like to spin something in here. You know that a couple of months ago we announced a 5-year warranty
Right.
on all our timepieces, and even a 10-year warranty on silicium parts. Because once we have a silicium part in the timepiece, it doesn't break. But it needs an extra attention and a little bit of training for the watchmaker to put
Right,
it together.
right.
That's when they sometimes break.
That makes sense. Interesting. Okay, so this self-explanatory.
Yeah. Now, a bit
Gold
of a time
wheels.
issue, gold wheels, you know, with Sigatech and with Mimotech. Mimotech is the partner for us. With Sigatech, they have the Liga technology, which they master. And what they did now, we're producing with them whole wheel set out of 24 karat gold. Now,
And are they
karat,
forged?
No, they are built like the Liga technology. And that's
Really?
why we are able to make it very hard. So
And
it's
very
grown
precise.
like they're very extremely
So
precise.
let me see, why gold out of another metal? Why gold?
It's the efficiency. It's the friction and the efficiency, which is much better than steel or much better than brass.
Okay, so that's the missing part. Why
That's-
gold? Interesting.
exactly.
Not just to say there's more gold in
No,
the
no,
watch.
no, 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 no.
It has
And it's of course, again, it could be used in other technologies or in other industries. It's actually the fact that we can build it with Liga technology.
That's really cool. So this is the question I had. Glass.
Yes.
Like, what kind of glass?
Glass.
Glass
Real
glass?
glass.
Wow.
Not sapphire, glass. Ulysse Nardin was always experimenting with glass. About 20-30 years ago, we once produced a deck chronometer where the balance wheel was out of glass. So we experimented with glass historically. Now this timepiece here, if you take this plate, this whole bridge is built out of glass. It's one glass. With our laser technology, we are able to build in the shock absorber, which normally has 5-6 pieces at least, but it's one piece. The shock absorber, the bridge is one piece. On top of it, we are able, with the technology for which we have a patent pending, we have those so-called channels lasered into the glass, which we fill with superlumina. So I can show you here. If I go here, we have superlumina, which we can, with that technology, build in any shape and in any form.
That's super cool.
And if you see very close, you see the UN.
Mm-hmm.
The UN is lasered inside the glass, not on top of the glass, not on the bottom of the glass, but inside the glass.
So, okay, here's something that's interesting you have to explain. You're using something which is glass, which people think is delicate, as shock protection.
Yes.
Explain that.
Well, the shock is of course minimal,
Right.
let's put it this way, and the way it is constructed here, it's constructed with a lot of technology behind it, which means the shock is absorbed not only in one direction, but in a few directions. And it makes the shock absorber go back, or the pin go back into position right away after it gets the shock.
Okay, we have so two more. We have the display. So how does this work here?
The display, if you see here, you have an 24 indication or military time. If you go back, I suggest you go back. So we have now the indication from 1300 to 2300.
Oh, I get it.
If you go back, it flips. So midday, it flips from a display from 1 to 11 to a display from 13 to 23. And like always with Ulysse Nardin, it goes backwards and forwards.
That's incredible.
And for that system, not the display existed some years back in the 1960s. There was a company that had this kind of display, but not the kind of mechanism.
Very clever, very clever. So this is a concept watch, and this is not going to be built, but the idea is that this technology will fall into other watches later
Exactly.
on. How soon do you think? Is this something next year? Is this something 5 years from
I would
now?
hope that something of those 10 we will find in a timepiece next year already.
Okay.
But I would not make the promise.
Okay, so
I'm
again...
fairly sure by SIHH 2019 you will see at least one of those in our timepiece. But one thing is important. We will only do anything which you see here if we see a benefit for the end consumer. We will not do it just for a marketing stunt. We will only do it if we know there's a benefit for the end consumer.
So this has been the Ulysse Nardin InnoVision 2 with 10 innovations. Super cool. Patrik, thank you so much.
Thank you. Good to see you. Thank you.